see if it is working. I think it's where did I put this stuff? I think that's there. And let's just make a new file. Or do I have stuff? Intro. Let's see. Yeah. So that's where we did the polynomials last time. And we see polynomials from string. Polynomials are actually pretty useful. It's not. Let's just hope that everything is fine. Okay. So we got the polynomial stuff here, and we have the thing to find roots and to integrate. We have a testing function here. Testing function here that we can use to make sure our techniques work as they should. Okay, so instead of reading it from a string, which is the general idea, let's just make a function a special case of the general idea that gives you a polynomial of degree 3 the way you want it. Okay, let's go there. So the polynomial is going to be c plus bx plus ax squared. Poly p don't remember how the conventions were set up. Alec poly, that's what we want. So to say address to to a polynomial, you need to use this symbol. So this is a pointer to P, but to write it, you have to say that's the address of P. And then the degree is degree 2. After that point, we can write P.cof of 0 equals C, P.cof 1 equals B, P.cof 2 equals A. And then return B. See if that compiles. Took a really long time. I think it's because so you see, just a note. This is what it looks like when you read some bits in the memory, and just imagine they are a floating point number. That's what it looks like. You could sort of reverse, go the other way and figure out what the pattern of bits in memory is to give you that number. If you want to, if there's something not working, you could even write a small program just to do that automatically. It would change if you go from C to some other language, but after that it's just one convention. So you just gotta know the convention, read it somewhere, and then write a program. Another thing you can do, actually, if you have access to the actual memory location, you can just read it as something else, you know, cast it and read it as just a unsigned integer. So that you just get the raw bit pattern. But depending on various things, it might not be the actual bit pattern. Okay, so it worked. And then if you run it, yeah, it doesn't take that much time. So that's just a simple case, but it's going to be relatively useful to us. Right. And we can also make another special case. It's just going to be some copy paste. All right. If you're not familiar with this text editor, the usual copy paste you would think would work will not work. it's the meta key W to copy and the control key Y to paste. Just if you're if you want to use Emacs but don't know the command at this moment. Right, so that's what it is. Okay, so then we have to figure out a few things. All right, one of the things that's pretty important is you know, how to represent functions in the computer, like actual functions like in mathematics. Alright, not procedures, but just something that takes an input and gives an output. How to represent, so okay, so here is a few ideas. The way we write down functions in physics, some functions that we write down, you know, pretty simple. It's just expression. So say you want to write x squared minus 1, right? Or maybe the right word would be code here. Just if you want to write down this function, well, you can just write a program that computes this function, right, yourself every time. That's fine if you just want to use one function and be sure it's fast and so on. So you just write the code, right? You write x times x minus 1 or whatever. And then so if you want, you can use other techniques. For example, you can write it with symbols, right? If you think about how you represent this function on a piece of paper, you write like x squared minus 1, and it's not actually a program per se. It's like, or it's not a machine to produce an answer given an input. It's not a black box that you don't see the inside and you just see x coming in and some result coming out. It's actually you have 1, 2, 3, 4, 5. You have 5 symbols, right? You have 5 symbols that you write down on a piece of paper, and that specifies what function you mean. And then if you give the function to somebody else on the piece of paper, they could write the program, right? They could write a program, or they could execute. They could compute it themselves by putting x, and they know that when there's this squared, they have to use the rule that they have to square x, and then there's minus 1, they have to minus 1, right? When I say there is this minus 1, I mean on the piece of paper there is minus 1. Minus 1 is written on the piece of paper. When I say they subtract 1, I mean they're doing a physical process of subtraction, right? They're not just writing minus 1 on a piece of paper. If the number is 27, they're not writing 27 minus 1, they're writing 26, right? So they're doing the computation. But they could also just write a program that does the computation. So